equals x plus x square. Replace x by minus x. Very simple. Yes, x square equals 2, and this implies that x equals plus minus square root 2. This is an odd function. So we write the answer. Given that fx equals this, gx equals this, and hx equals this expression, and we have to find the formula for this composite function. Yes, this type of function is known as composite function. So first we will determine g of h of x. Okay, so what is g of h of x? So what we will do, we will substitute the value of hx in place of x. Okay, so we just replace x by hx, and we obtain g of hx equals 1 by hx, because gx is defined as 1 by x. So we just replace this. Okay, now we know hx equals this one, therefore directly substituting the value, we obtain g of hx equals 1 by x square minus 1. Now we have to determine f of g of hx. Can you do this? It's simple. We just have to replace the x with this expression the same way as we have finished this one. Yes, so f of g of hx, this will be, let's say this equals y. Okay, so how f x is defined? F x is x by x minus 1. Therefore if we assume this as y, f of y, we know from the definition this is y by y minus 1. Now what we assume as y? Our y equals g of hx. Therefore substituting the value of y, we obtain g of hx. Similarly here, g of hx minus of 1. Now our g of hx, it is from here. So it's simple, just substituting the value once again here. We have g of hx equal 1 by x square minus 1. G of hx 1 by x square minus 1. Now if we simplify this, since we do not have enough space here, let's write down here. So if we simplify this, we obtain 1 by x square minus 1. Then here 1 minus x square minus 1, and this x square minus 1 will go in the numerator, this x square minus 1 and this x square minus 1 will get cancelled out. Yes, and in the denominator if we simplify, we obtain 1, it is 2 minus x square. Yeah, so we obtain this composite function f g h x, which can also be written in this way as 1 by 2 minus x square. Okay, let me just box this with a different color. So this is our answer. Now we have another additional question here, that we have to state the domain of this composition. Yes, so what is the domain of definition? So what is the meaning of this, that we have to state the domain of this composition? So we have to exclude those points that makes the function undefined. Yes, we have our function as 1 by 2 minus x square. Now the domain of this function, of this composite function, it means we have to exclude all those values of x for which these functions became undefined. That is like 1 by 0 or 1 by infinity or infinity by infinity or 0 by 0. these are the 4 undefined form. Yes, so we have to check out that this function should not attain any of these such values, or whatever you can say. These are not values, these are undefined thing. So can you say that at which values of x these things occurring? Now observe that this is not possible in this case, because in the numerator we already have 1. This is also not possible. Yes, so these 2 things gets excluded, remains this one and this one. Now from here this is also not possible, because this is not in that form, right? So left only this one. And when this thing will occur, it will occur when x square equals 2, and this implies that x equals plus minus square root 2. Therefore we have to exclude this value. X square should not be equal to, okay? Otherwise this function will be undefined. Therefore the domain of definition of this function, it can be written in this way: 2 minus x square, and the domain of definition we should exclude x is not equal plus minus square root of 2, okay? Or you can say that x square is not equal to. Why? Because otherwise the function will become in this form. It is in undefined form it is obtaining. Yes, okay. In each part classify the function as even, odd, or neither. Now what is the definition of an even function and odd function? Let's say f is a function. We will call this as an even function if we can write the function in this way: f of minus of x equals fx. This is the definition of even function. For example, let's say fx equals x square. Now f of minus x, what we obtain? Minus x whole square. This equals x square. Therefore we can write f of minus x as f of x. Yes, so this is an even function, right? Similarly, let's say fx equals x. F of minus x equals minus of x. We obtain here this as minus of fx. F of minus of x equals minus of fx. Now function of this type is called odd function, okay? When we have f of minus of x equals minus of fx, this type of function is known as odd function, okay? So f of x equals x, this is an odd function. F of x equals x squared, this is an even function. Or else you can also prove or show it that, or you can even try it in your home, that any function of odd power, say 3 or x5 or x7, these are all odd function, okay? You can check it by yourself. And any function of this type, even power, x to the power 4, x to the power 6, 8, these are all even function, okay? This is odd function, this is even function, okay? So you have to verify this, that which one of this is either odd, even, or neither. Function can be even, odd, or neither. So let's check the first one. Let's take some different color. We have a. Let's take fx equals x square sine x. Now from the definition, let's replace x by minus x. Then here we obtain minus of x whole square sine of minus of x. Now minus of x whole square, this gives us x square, and we know sine of minus of x, sine of minus of x equal minus sine x, right? Yes, therefore from here we obtain this as minus of sine x, this gives us minus x square sine x, this equals minus of fx. Therefore this is an odd function. So we write the answer odd function, okay? Similarly, Problem B, let's take fx equals, would you like to try this by yourself? Try it, pause the video, try it by yourself and come and check. Meanwhile, I am finishing this. F of minus of x, replacing x by minus of x, we can write this in this form. Now we know this equals minus of sin x whole square equals sin square x. Yes, and we obtain this as fx. F of minus x equals fx, we obtain. Yes, so this is an even function. Yes, this is an even function from the definition. Similarly, problem C, let's take fx equals x plus x square. Replace x by minus x, very simple. Yes, plus we just have to replace x by minus of x, that's all, and then simplify and then see what is obtaining. Okay, minus of x plus x square. Now see here, we cannot write this as in this form, right? Because here the function is getting completely changed. The symbol is not changing only, everything is getting changed. So the function is getting completely changed. So this is neither even, neither odd. Yes, so this is neither. Yeah. The final problem D, let's take same procedure. Sin x, tan x. My handwriting is little bit fuzzy, I think you guys still can understand. So f of minus x, we have sin of minus x, tan of minus x. Now we know minus sin of minus x is minus sin x. Yes, and tan of minus x is minus tan x. Multiplying, minus minus multiply will be plus, and ultimately we obtain sin x tan x, that is, this is fx again. So f of minus of x equals fx. This is again an even function.